Let's move on to the next question. Question number 13. The vectors AB bar equal to 3i plus 4k and AC is equal to 5i minus 2j plus 4k are the sides of the triangle ABC. The length of the median through A is, first option root 18, second option root 72, third option root 33, and fourth option is root 288. Now let's have a look at this. We have a triangle ABC. AD is the median through A. If I assume A to be origin, then the position vector of B will be the same as the vector AB. What is the vector AB given to be? 3i plus 4k. Now that is going to be the position vector of 3B here. I am assuming A to be origin. Similarly, if now AC vector is given to be 5i minus 2j plus 4k. So the position vector of this will become 5i minus 2j plus 4k. Now D being the midpoint of BC, the position vector of this will be B bar plus C bar by 2. So the position vector of B plus position vector of C by 2. We have here 5 plus 3, 4, 5 plus 3 by 2, 4i, and then we have minus j and then 4k. So that is going to be the position vector of D. Now what about the vector AD then? AD vector is given by, I can say in fact it is AB plus AC by 2, and that is 4i minus j plus 4k. So clearly the magnitude of AD is equal to under root of 16 plus 1 plus 16, and that is equal to 33 under root. So the right option is option 3 is the right answer. Let's move on to the question number 14. A particle is acted upon by constant forces 4i plus j minus 3k and 3i plus j minus k and is displaced from the point I plus 2j plus 3k to the point 5i plus 4j plus k. The total work done by the forces is, first option 20 units, second option 30 units, third option 40 units, fourth option 50 units. Now we have a particle at some position A, let us say. Its position vector is I plus 2j plus k, I plus 2j plus 3k. And now the particle is displaced from A to some point B. The position vector of that point B is 5i plus 4j plus k. So what is the displacement vector? AB vector is given by position vector of B minus position vector of A, that is 4i plus 2j minus 2k. Now when the particle is moving from here to here, it is being acted upon by two constant forces. So what is the resultant force? F resultant is sum of the two forces given, F4i plus j minus 3k plus 3i plus j minus k. And what is this going to be? 7i plus 2j minus 4k. The work done is given by F dot S. What is that S? That is displacement vector. So let's take the dot product with these two, of these two. So 7 into 4, 28. 28 plus 4, 32. 32 plus 8, that is 40. So 40 units. Let's move on to the next question. Question number 15. Let u bar be equal to I cap plus j cap, v bar be equal to I cap minus j cap, and w bar is equal to I cap plus 2j cap plus 3k cap. And if n cap is a unit vector such that u bar dot n cap is 0 and v bar dot n cap is equal to null vector 0, then w bar dot n cap is equal to first option 0, second option 1, third option 2, fourth option minus 3. We are given that n cap dot u bar is 0 and so is n cap dot v bar. That means n cap is perpendicular to both u bar and v bar. So that means n cap must be parallel to u cross v. So we will take the cross product of u and v, but he says it's a unit vector, so it should have been magnitude of, you'll have to divide by the magnitude. So n cap, because it's perpendicular to u and v, it can be written as lambda times u cross v. Now, but since we are interested in n cap being a unit vector here, we'll have to divide by the modulus of u cross v. So we have here, this is I plus j cross product with I minus j divided by the magnitude of it. Now this I plus j by I plus j cross I minus j, I cross I is 0, I cross minus j will be k, minus k, and what about j cross I, that's under k, minus k, so we get a minus 2k there, divided by, so modulus of minus 2k here. So modulus of minus 2k, and that turns out to be, what does it turn out to be? It turns out to be minus k there. This is minus 2k divided by 2 there, so that makes it minus k. So n cap is minus k for us. And what are we interested in? W bar dot n cap. W bar dot n cap. So that is equal to I plus 2j plus 3k dot product with minus k cap, which is nothing but minus 3. So the option 4 is the right answer. Option 4 is the right answer. Let's move on to the next question. Question number 16. Let u bar, v bar, w bar be such that magnitude of u is equal to 1, magnitude of v is equal to 2, magnitude of w is equal to 3. If the projection of v bar along u bar equals to the projection of w bar along u bar, and v bar and w bar are perpendicular to each other, then magnitude of u bar minus v bar plus w bar is equal to first option 2, second option root 7, third option root 14, fourth option 14. Now what are we given? We are given the magnitude of u to be 1, magnitude of v to be 2, and magnitude of w to be equal to 3. Okay. Now what else we are given? The projection of v bar along u bar. So what is the projection of v bar along u bar? V bar dot u bar divided by the magnitude of u bar. That is same as the projection of w bar along u bar. So w bar dot u bar divided by the magnitude of u bar. But then magnitude of u bar is 1, u bar being a unit vector here. So what we have here is v dot u to be same as w dot u. In other words, we can say w minus v dot u is equal to 0. Dot product is distributive over addition or subtraction. So we can write w dot u minus w dot v dot u to be 0. Therefore, that is equal to w minus v bar dot u equal to 0 here. Now what do we want? We want magnitude of u minus v plus w. Let's consider the square of it. That turns out to be magnitude of u square plus magnitude of v square plus magnitude of w square minus of 2 into u dot v minus plus 2 into u dot w minus 2 into v dot w. Okay, let's observe these two things here. Magnitude of u square plus magnitude of v square plus magnitude of w square will be equal to 1 square plus 2 square plus 3 square. I say the rest of the terms are all 0. He has given that v bar and w bar are perpendicular. So v bar dot w bar is also given to be 0. This is given. So this term is 0. Moreover, you can take u bar common and you have here w bar minus v bar dot u bar. So this part can be clubbed into 2 times of w minus v times of u, dot product with u. These two terms can be clubbed, and which is already known to be 0 here. Therefore, we have here the entire thing turns out to be 1 square plus 2 square plus, that is nothing but 14. So therefore, the magnitude of u minus v plus w will be equal to under root of 14. The option is, right option is option 3 is the right answer. Let's move to the next question, question number 17. The distance between the line r bar equals to 2i minus 2j plus 3k plus lambda times I minus j plus 4k, and the plane r bar dot I plus 5j plus k is equal to 5 is first option 10 by 9, second option 10 by 3 root 3, third option 3 by 10, and fourth option 10 by 3. Let's have a look at this. We know that a line is given by, a line can be represented with the help of a point on the line and a vector parallel to it. So if you know one point on the line and one vector parallel to the line, we can write the equation of the line as r bar equal to a bar plus lambda times v bar, where lambda is a parameter here. How does it come out? R bar is any point on the line. So r bar minus a bar will be parallel to b bar. Therefore, r bar minus a bar we can write it in the form of lambda times b bar. So we have this. So the first line is given to be in that form. What is that line given to be? It's given, instead of a bar we have 2i minus j, 2j plus 3k. And instead of this vector which is parallel, we have I minus j plus 4k. Now let's observe one thing. We are given the equation of a plane as well. We are given a plane. The plane is in the form of r bar dot I plus 5j plus k is equal to 5. Okay. Now observe that when we write the equation of the plane like this, r bar dot n bar equal to some d. Now this n bar represents the vector normal to the plane. So what is n bar here? I plus 5j plus k is a vector normal to the plane. Let's make one observation here. This line is actually parallel to this plane. The given line is parallel to the plane. How do we observe that? We observe that this b bar dot n bar is 0. B bar is like this and n bar is like this. B bar is and n bar is like this. So when the line is parallel to the plane, the vector parallel to the line should be perpendicular to this normal to the plane. So what should we have? Let's check it. Let's see whether b bar dot n bar is 0 or not. Let us verify this. I dot I mean this I minus j plus 4k dot product with this, we get 1 minus 5 plus 4, that makes it 0. It is true. So that means that this line is actually parallel to the plane. So when you have a line parallel to the plane, the distance from the line to the plane will be, take any point on the line and drop a perpendicular. That distance will be the distance. And we know that when the plane is given to be r bar dot n bar minus some d equal to 0, when the plane equation is like this, and you have a point a bar not on the plane, the perpendicular distance is given by a bar dot, this distance is given by the formula a bar dot n bar minus d divided by modulus of n bar. The whole thing under modulus. This distance, okay, let's call this as p. P, the perpendicular distance, is given by that. So we can use that formula now. That is, when you have a point a bar not on the plane and the equation of the plane is given by r bar dot n bar minus d is equal to 0, then the perpendicular distance from the point to the plane is given by a bar dot n bar minus d divided by magnitude of n bar. That is, simply replace r bar by a bar, this point, and then write it. Okay, so here what do we need to do? We have that equation like this. So instead of a bar we have here 2i minus 2j plus 3k. Dot product with this n bar, what is that n bar? I plus 5j plus k minus this 5 divided by magnitude of I plus 5j plus k. The whole thing under modulus. So that comes out to be 10 by 3 root 3. A simple calculation will show us that this comes out to be 10 by 3 root 3. Therefore, the option 2 is the right answer. Let's move on to the next question. Question number 18. For any vector a bar, the value of a cross I square plus a cross j square plus a cross k square is equal to, first option 3 into a bar square, second option a bar square, third option 2 into a bar square, fourth option 4 into a bar square. So let's have a look at this. A bar is some vector. Let us take it as some xi cap plus yj cap plus zk cap. Let a bar be this. What is a cross I? That's going to be y into j cross I, that's going to be minus yk. Z into k cross I will be j. So zj minus yk. What is a cross I square? Square of a vector is nothing but the dot product of the vector with itself. So what do we have here? You get y square plus z square. Magnitude of it. So square of the magnitude of it. Okay, similarly, what will be when you are taking the cross product with I cap, you have the other two components y and z here. So when you take the cross product with j cap, you should get the other, apart from this component, should get the other two. So you should have x square plus z square. And a bar cross k cap whole square will be, what is that? X square plus y square now. So when you add up all these three, summing up, we get on the right hand side 2 times of x square plus y square plus z square, which is nothing but 2 times of magnitude of a square. So 2 into a bar square. Therefore, the option 3 is the right answer. Let's move on to the next question. Question number 19. If u cap and v cap are the unit vectors and theta is the acute angle between them, then 2u cap cross 3v cap is a unit vector for, first option, exactly 2 values of theta, second option, more than 2 values of theta, third option, no value of theta, fourth option, exactly 1 value of theta. So let's have a look at this. We are given that u cap, magnitude of u cap is 1, of course magnitude of v cap is 1 because they are unit vectors, and the angle between u cap and v cap is theta. This is also given to be acute. So between 0 and 90. Okay. Now you are also given that 2u cross 3v cap, this is a unit vector. What is this? Magnitude of this is equal to 6 times of magnitude of u cap cross v cap. That's equal to 1. But what is the magnitude of u cap cross v cap? That's going to be 6 into magnitude of u cap into magnitude of v cap. That's anyway 1 each, into sine of the angle between them, sine theta. That is equal to 1. So sine theta has to be equal to therefore 1 by 6, because each is 1 here. Sine theta is 1 by 6. Now sine theta being 1 by 6, let's look at the sine graph. It goes like this: y equal to sine x. Y equal to sine x graph goes like this. 1 by 6, y equal to sine x equal to 1 by 6. Between 0 and pi it can happen for 2 values, but between 0 and pi by 2 it can happen only for 1 value of theta or 1 value of x. So sine theta being 1 by 6 and theta being acute can happen only for exactly 1 value of theta. This is 1 by 6. So there exists exactly 1 theta belonging to 0 comma pi by 2 such that sine theta is equal to 1 by 6, which means that there will be exactly 1 theta satisfying the entire information. So answer is option 4 is the right answer. Let's move to the next question, question number 20. The vectors a bar and b bar are not perpendicular, and c bar and d bar are two vectors satisfying the condition that b cross c is equal to b cross d and a dot d is equal to 0, then the vector d bar is equal to, first option, b bar plus b dot c divided by a dot b times c bar. Second option, c bar minus a dot c divided by a dot b times b bar. Third option, b bar minus b dot c divided by a dot b into c bar. Fourth option, c bar plus a dot c divided by a dot b into b bar. Now we are given that a bar and b bar are not perpendicular. So first of all, a bar dot b bar is not equal to 0. And what else C is given? B cross C is equal to B cross D. So in other words, taking B common here, B cross C bar minus D bar is equal to 0. What does this imply? When is the cross product of two vectors 0? When the two vectors are parallel. So we can write B bar to be equal to lambda times C bar minus D bar. We can write B bar to be equal to lambda times C bar minus D bar, or C bar minus D bar, you can write it as lambda times B bar. Either way, we can write C bar minus D bar to be lambda times B bar. So C bar minus D bar is equal to your lambda B bar, or D bar will be equal to C bar minus lambda B bar. So let's keep it aside. This is one observation for some lambda. So if I am able to find that lambda, we are done. Now as of now, D bar is a linear combination of C bar and B bar, and all the four options we are, as you see, have vectors which are in this form, which is a linear combination of. So I need to just find out this lambda here. To find that, we got to make use of some other information there. What else we have here? D bar dot A bar is given to be 0. This is also given. So what does that give me? It gives me C bar dot A bar minus lambda times B bar dot A bar is equal to D bar dot A bar, that is 0. Therefore, lambda will be equal to C dot A divided by B dot A. So now just we'll got to substitute this lambda value here. Hence, our d bar is equal to c bar minus lambda b bar. That is, instead of lambda, I'll write this c dot a divided by b dot a is our lambda, that into b bar. So clearly, that's option 2 is the right answer. Option 2 is the right answer. So let's move on to the next question, question number 21. Let a bar and b bar be two unit vectors. If the vectors c bar equal to a bar plus 2b bar and d bar is equal to 5a bar minus 4b bar are perpendicular to each other, then the angle between a bar and b bar is, first option pi by 6, second option pi by 2, third option pi by 3, and fourth option pi by 4. So let's have a look at this now. What have we given? See, a bar and b bar are unit vectors. So magnitude of a bar is 1 and magnitude of b bar is also 1. What you want is the angle between them. So let angle between a bar and b bar be theta. What is cos theta given by? Cos theta is given by a bar dot b bar divided by magnitude of a bar into magnitude of b bar. Since both the magnitudes are 1, we can simply write a dot b. So what we want is actually a dot b. What are we given? C bar is equal to a bar plus 2b bar. A bar plus 2b bar. And d bar is equal to 5a bar minus 4b bar. We are also given that c bar and d bar are perpendicular, therefore the dot product has to be 0. Let's take the dot product of these two. So we can simply multiply 5. What do we get? 5 into magnitude of a square minus 8 into magnitude of b square, and then you have a 10 into a dot b, 10 minus 4, 10 minus 4 into a dot b. The whole thing is equal to 0. What is this? What is magnitude of a? 1. So what is magnitude of b? That's also 1. So what we have here, 5 minus 8, that makes it minus 3, and we have here 6. 6 into a dot b is equal to, that minus 3 carried this side will give me 3 here. So a dot b is therefore equal to 3 by 6, which is nothing but our cos theta. So cos theta, which is equal to a dot b, is equal to 1 by 2. This implies theta has to be pi by 3. Therefore, the option 3 is the right answer. Let's move on to the next question. If a bar is equal to pi plus 3j minus 7k and b bar is equal to pi minus pj plus 4k, and if the angle between a bar and b bar is acute, then the values of p lie in the range. First option, p less than minus 4 or p greater than 7. Second option, p lying between minus 7 to 4 open interval. Third option, p belongs to the closed interval minus 7 open 4. And fourth option, p belongs to the closed interval minus 7 comma 4. So let's have a look at this. When is the angle between two vectors acute? Cos theta must be positive. If theta is the angle between a bar and b bar, the angle is acute if and only if cos theta is positive. So what is cos theta? The dot product divided by the magnitudes. Anyway, the magnitudes are positive, so a dot b has to be positive. This is cos theta is nothing but a dot b divided by magnitude of a into magnitude of b. Now this is already positive, always positive, whatever may be a bar and b bar. So the sign of cos theta will actually depend on a dot b. So let's look at a dot b. What is a dot b? A bar dot b bar. A bar is given to be pi plus 3j minus 7k. And now let's look at B bar. B bar is given to be Pi minus Pj plus 4k so the dot product will be P square minus 3P minus 28, which we can conveniently write it as P minus 7 into P plus 4. Factorize it as P minus 7 into P plus 4. So when is this P minus 7 into P plus 4 positive? So that happens, mark it on the number line, minus 4 and 7 will be the deciding numbers for the sign pattern of this expression. That happens beyond this minus 4 and 7. So P should be less than minus 4 or P should be greater than 7. So the right option is option 1. Option 1 is the right option. Let's move on to the next question, question number 23. If 2 out of the 3 vectors A bar, B bar, C bar are unit vectors and A bar plus B bar plus C bar is equal to null vector and 2 times of A bar dot B bar plus B bar dot C bar plus C bar dot A bar plus 3 is equal to 0, then the length of the third vector is first option 3, second option 2, third option 1, fourth option 0. Now let us assume out of A, B, C, magnitude of A and magnitude of B are both equal to 1. We got to find out the magnitude of C. Is what we want. He says 2 of the 3 vectors are unit vectors. So let's assume that without loss of generality that magnitude of A and magnitude of B are both equal to 1. And now let's look at here something is given about A bar plus B bar plus C bar. What's that? It's a null vector. So the magnitude of that also has to be 0. The square of it has to be 0. But what is the magnitude of A plus B plus C the whole square? Magnitude of A square plus magnitude of B square plus magnitude of C square plus 2 into A dot B plus B dot C plus C dot A. The whole thing is equal to 0. Out of them, what we know are these, and this 2 into A bar dot B bar plus B bar dot C bar plus C bar dot A bar is given to be equal to minus 3. So this part is given to be minus 3 and these two are equal to 1 each. Okay, so 1 plus 1 minus 3 plus magnitude of C square is equal to 0. So what is magnitude of C square? 3 minus 2, that is equal to 1, and magnitude of C therefore is equal to 1. Has to be a positive quantity. So we have a 1 there, and clearly the option 3 is the right answer. Option 3 is the right answer. Let's move to the next question, question number 24. The locus of the point equidistant from the two given points A bar and B bar is given by R bar minus half of A bar plus B bar dot product with A bar minus B bar equals to 0. R bar minus half of A bar minus B bar dot product with A bar plus B bar is 0. Third option, R bar minus half of A bar plus B bar dot product with A bar plus B bar is equal to 0. Fourth option, R bar minus half of A minus B dot product with A minus B is equal to 0. Now here R bar is a general point on the locus. That's what we should understand here. A bar and B bar are 2 points. Now R bar is moving in such a way that its distance from A bar is same as the distance from B bar. So it's clear that R bar has to be along the perpendicular bisector of AB segment. So what is the midpoint of AB? That's given by A bar plus B bar by 2. Now this vector, let's call this as P and C, PC vector. P is a general point on the locus. PC vector is perpendicular to AB vector. PC dot AB has to be 0. But what is PC? PC is R bar minus A bar plus B bar by 2. What about the vector? What about the vector? I mean, we can write CP. It is CP vector actually. CP or PC, it doesn't matter because you have the right hand side to be 0 anyway. So R bar minus A bar plus B bar by 2 dot product with AB. What is AB? B bar minus A bar is equal to 0. Whether it is A bar minus B bar or B bar minus A bar. We can even write it as R bar minus half of A plus B dot product with A bar minus B bar equals to 0. So this R bar, a general point on the locus, will have to satisfy this equation, and clearly option 1 is the right answer. Option 1 is the right answer. Let's move on to the next question, question number 25. Let A bar, B bar, C bar, D bar be the position vectors of 4 points A, B, C and D respectively on the plane such that B bar plus C bar minus 2D bar dot product with B bar minus C bar is equal to C bar plus A bar minus 2D bar dot product with C bar minus A bar is equal to 0. Then the point D is of the triangle ABC is first option in center, second option circumcenter, third option orthocenter and fourth option centroid. Now we are given a triangle with position vectors as ABC and we are asked to comment about the position vector D. Now how is this? We are given that B bar plus C bar minus 2D bar dot product with B bar minus C bar is 0. That's one condition given. I will rewrite this equation this way. I will take out 2 common and write this as B bar plus C bar by 2 minus D bar dot product with B bar minus C bar is 0. Now what is B bar plus C bar by 2? It is B bar plus C bar by 2 is the position vector of the midpoint of BC. Now what is this vector? Must have been, if I call this as some L, this point L, this D is some point so that DL, this is the vector DL or LD, this is D bar. We observe that DL vector is perpendicular to BC vector. Okay, so this is the point D. So that means our point D must have been on the perpendicular bisector of BC. Observe that this is the vector DL. This is the vector 2 times DL dot CB vector. That is 0. So what does it mean? D must have been a point on the perpendicular bisector of BC. Similarly, the second condition, we can rewrite the C bar plus A bar minus 2D bar dot product with C bar minus A bar equals to 0. That also can be interpreted like this. We can take out 2 common and then write this as C bar plus A bar by 2 minus D bar dot product with C bar minus A bar is equal to 0. What is the C bar plus A bar by 2? That must have been the midpoint of this. Midpoint of AC. C bar plus A bar by 2. Let's call this as some M. Okay, let's call that as M. Now this I can write this to be some DM. Right? This is our DM. This we can write it as DM. So 2 times of DM dot product with, what about this AC is 0. So DM is perpendicular to AC as well. So now this also must have been the perpendicular bisector of AC. So D lies on the perpendicular bisector of AC and also the perpendicular bisector of BC. What is the point of concurrence of 2 perpendicular bisectors of a triangle? The point of intersection of the perpendicular bisectors of any 2 sides of a triangle is nothing but the circumcenter. So here we have D must be the circumcenter. D must be the circumcenter of the triangle ABC. As it lies on two perpendicular bisectors, it has to be the circumcenter of the triangle ABC. And therefore, clearly the option 2 is the right answer. Let's move on to the next question. Question number 26. If A bar is equal to A1i plus A2j plus A3k, and B bar is equal to B1i plus B2j plus B3k, and C bar is equal to C1i plus C2j plus C3k, and C bar is a unit vector perpendicular to the plane of A bar and B bar, and the angle between A bar and B bar is pi by 3, then the determinant A1, A2, A3, B1, B2, B3, C1, C2, C3 the whole square is equal to, first option 0, second option 1, third option 3 by 4 times magnitude of A square into magnitude of B square, and fourth option 3 by 4 times A1 square plus B1 square plus C1 square into A2 square plus B2 square plus C2 square. So let's have a look at this here. Now A bar is equal to A1i plus A2j plus A3k. And B bar is equal to B1i plus B2j plus B3k. C bar is equal to C1i plus C2j plus C3k. This determinant A1, A2, A3, B1, B2, B3, C1, C2, C3, square of it is nothing but box of ABC the whole square. But then there is one more result which says that box of ABC whole square is equal to the determinant A dot A, A dot B, A dot C, B dot A, B dot B, B dot C, C dot A, C dot B, C dot C. What are we given about ABC? He says that C bar is a vector which is perpendicular to both A and B. So what is that? C bar is nothing but A cross B divided by magnitude of A cross B. So C bar is a unit vector orthogonal to the plane of A and B. Therefore, I can say that C bar is nothing but A cross B divided by magnitude of A cross B. So we have C bar dot A bar to be 0, C bar dot B bar also is to be 0 here. So we'll have a 0 here, these two being zeros here. What else is given about A bar, B bar? Magnitudes we don't know, so we'll just write it as magnitude of A bar square, and A bar dot B bar, we will leave it as it is. This is A bar dot B bar. A bar dot B, C bar is 0. And here again we'll write this as A bar dot B bar. Magnitude of B square. Okay, what about here? This is 0, this is 0, 0, and then C is a unit vector, so magnitude of C is 1. So what we have here is, we have therefore this to be equal to, when you open up this determinant, it comes out to be magnitude of A square into magnitude of B square minus A dot B the whole square. A dot B the whole square. Now what is this magnitude of, what is A dot B? A dot B is, we know A dot B to be equal to magnitude of A into magnitude of B into cos of the angle between them. What is the cos of the angle between them? 1 by 2, because theta is pi by 3 there. So A dot B is magnitude of A into magnitude of B into 1 by 2. So that makes it. Therefore, coming back to this, we can write this as magnitude of a square into magnitude of b square taken common into 1 minus 1 by 4. Because a dot b is magnitude of a into magnitude of b by 2, so that 1 by 2 square, we'll get it this way. So that comes out to be 3/4 of magnitude of a square into magnitude of b square. So clearly the option 3 is the right answer. Option 3 is the right answer. Let's move on to the next question, question number 27. If a bar, b bar, c bar are three non-zero vectors such that magnitude of a cross b dot c is equal to magnitude of a into magnitude of b into magnitude of c, then magnitude of a plus b plus c the whole square is equal to, first option 0, second option 1, third option is magnitude of a square plus magnitude of b square plus magnitude of c square, and fourth option is -1. Clearly fourth option cannot be the answer because you have magnitude square that has to be always non-negative, so you can't have fourth option to be right. That is ruled out from the very observation. Now let's move on to the condition given there. Modulus of a cross b dot c is given to be magnitude of a into magnitude of b into magnitude of c. When is this possible? Okay, first of all, what is the left hand side? Left hand side is the product of magnitude of the product of dot product of the two vectors. So what do we get here? It's magnitude of a cross b into magnitude of c into cos of the angle between a cross b and c. A cross b and c. What else we can say about this? Let us say this angle is some theta 1. So cos theta 1. That is, the angle between a cross b, a bar and b bar are like this. A cross b would have been like this. The angle between a cross b and theta as c bar, we are calling it as cos theta 1, theta 1. So we have cos theta 1. Okay. Now what about this? This is magnitude of a into magnitude of b into sine of the angle some theta 2 angle between these two into cos magnitude of c into cos theta 1. This is what is our left hand side. But then that has been to be equated to magnitude of a into magnitude of b into magnitude of c. That makes it sin theta 2 into cos theta 1 must be 1. When is this possible? When both of them are at 1. So theta 1 must have been 0 and theta 2 must have been equal to pi by 2. So this means that a and b are perpendicular. So a bar dot b bar is 0 and this angle between a cross b and c is 0. So c is parallel to a cross b, which in turn implies c bar dot a bar is 0 and c bar dot b bar is also 0. See, the angle between c bar and a cross b is 0 because theta 1 I am getting it to be 0. So which means that c bar must have been parallel to a cross b. So that means c bar must have been perpendicular to a bar as well as perpendicular to b bar. Therefore, we have c bar dot a bar 0, c bar dot b bar 0. Very clearly now, magnitude of a plus b plus c the whole square will be magnitude of a square plus magnitude of b square plus magnitude of c square plus 2 into sigma of a dot b there. All that are zeros because a dot b is 0, b dot c is 0 and a dot c is also 0. So each of these terms is 0. So we're just getting out to be magnitude of a square plus magnitude of b square plus magnitude of c square. That's what it's turning out to be. So option 3 is the right answer. Okay, let's move to the next question. Question number 28. If a into alpha cross beta plus b into beta cross gamma and c into gamma bar cross alpha bar is equal to a null vector with at least one of ABC non-zero, then the vectors alpha bar, beta bar, gamma bar are first option coplanar, second option mutually perpendicular, third option parallel, fourth option none of these. Let's have a look at this. Alpha bar cross beta bar, beta cross gamma and gamma cross alpha equated to null vector. Now with at least one of these ABC non-zero, what does that mean? When you have a linear combination of three vectors with the help of the three scalars ABC equated to null vector and with at least one of the scalars non-zero, it's a non-zero bar is expressed as a non-trivial linear combination of the three vectors, which means that the three vectors must have been linearly dependent and hence coplanar. So this implies actually alpha cross beta, beta cross gamma and gamma cross alpha, these are linearly dependent vectors and the box product of them has to be 0. Okay, so three linearly dependent vectors are also coplanar and hence therefore the box product has to be 0. But we know that the box product of this alpha cross beta, beta cross gamma, gamma cross alpha is nothing but box of alpha beta gamma whole square is 0. This is again a result that you got to keep in mind. So alpha cross beta plus beta cross gamma, gamma cross alpha, the box product of it is nothing but the box of alpha beta gamma this whole square. So if whenever this is 0, it means that the box of alpha beta gamma is also 0, which in turn implies that alpha beta gamma are coplanar vectors. So clearly the option 1 is the right answer. Let's move on to the next question, question number 29. If the vectors a bar and b bar are perpendicular to each other, then the vector v bar in terms of a bar and b bar satisfying the equations v bar dot a bar equals to 0, v bar dot b bar equals to 1 and box of VAB equal to 1 is first option b bar by magnitude of b square plus a bar cross b bar divided by magnitude of a cross b square. Second option b bar by magnitude of b bar plus a cross b divided by magnitude of a cross b square. Third option b bar by magnitude of b square plus a cross b divided by magnitude of a cross b. And fourth option none of these. So question number 29 here. What are we given? A bar and b bar. A bar is perpendicular to b bar, which in turn implies that a bar dot b bar is equal to 0. Okay, v bar dot a bar is 0 and v bar dot b bar is 1. So we have the vectors a bar and b bar to be perpendicular. So they are clearly non-collinear. So we can talk about a cross b. A cross b will be a vector like this. It will be mutually perpendicular to both a bar and b bar. So a cross b, a, b will be three mutually perpendicular vectors. They form a orthogonal triad, we can say. Here, any fourth vector in the space, when you have three non-coplanar vectors, any fourth vector in the space can be represented as a linear combination of these three non-coplanar vectors with the help of unique set of scalars, just like ijk. You take any vector, you can write it in terms of ijk. Not only ijk, you can take any three vectors which are non-coplanar in a space. A fourth vector can be represented as a linear combination of these three vectors. With respect to that vector, it will be a unique linear combination. So v bar, a fourth vector, we can write it as lambda times a bar plus mu times b bar plus some delta times a cross b. This a cross b is a vector like this, perpendicular to both a and b. Therefore, it is not in the plane of a and b. So we have three non-coplanar vectors A, B and A cross B. We can write any vector V bar this way. So let's use this information. V dot A is 0. So let's take the dot product, taking dot product with A. With A bar. What do we get? V dot A will be 0 and lambda into magnitude of A square. We get magnitude of A square here plus B dot A. He says that A and B are perpendicular, therefore B dot A is 0. So that is 0, mu into 0. And you know that the box product of three vectors where two of the vectors are same will be 0. So A cross B dot A will also be 0. So you get delta into 0. So what are we getting? Delta lambda to be 0. This implies lambda is 0. So this part is 0 then. This is 0. You get a 0 vector there. So what is our V bar? It's simply now mu into B bar plus delta into A cross B the square. A cross B. A cross B. What else? We know that V dot B is 1. So let's take the dot product with 1, B bar. So we get V dot B is equal to 1. Mu into B bar dot B bar is magnitude of B square plus A cross B dot delta times of A cross B dot B. What is A cross B dot B? This is 0. So this is 0. So we get again mu to be equal to 1 by magnitude of B square. Okay, therefore what do we have? V bar to be equal to 1 by magnitude of B square into B bar, because mu we got it to be 1 by magnitude of B square, lambda we got it to be 0, I am substituting, plus delta into A cross B. Now further, what else we are given? We are given that the box of VAB is 1. Is also given to us. Box of VAB is 1. By the way, what is box product of three vectors? That's nothing but dot V bar dot with A cross B. That's 1. So let's take the dot product with A cross B and we then get 1 is equal to 1 by magnitude of B square into B bar dot A cross B is anyway 0. So I'm going to get 0 here plus delta into magnitude of A cross B the square. Because a vector dot product with itself is magnitude of the square of the magnitude of the vector. So delta is equal to 1 by magnitude of A cross B square. So now let's substitute the value of delta here. What is delta? 1 by magnitude of A cross B square. Therefore, we have V bar to be equal to B bar by magnitude of B square, A cross B divided by magnitude of A cross B the square, and that's clearly seen in the option 1. So option 1 is the right answer. R bar is a vector such that R bar is equal to x times of B cross C plus y times of C cross A plus z times of A cross B vectors. Then magnitude of R bar dot A times of B cross C plus R bar dot B times of C cross A plus R bar dot C times of A cross B is equal to, the options are, first option the box of ABC, second option 1, third option modulus of box of ABC, fourth option 0. Now R bar is given to be x times of B cross C plus y times of C cross A plus z times of A cross B. Okay. Now what will be R bar dot A bar? R bar dot A bar is going to be x into B cross C dot A, and when you take the dot product of C cross A with A, it will be 0, so y into 0, and A cross B with A dot product with A also will be 0, so z into 0. So what we have here is R bar dot A bar will be simply x times the box of ABC because B cross C dot A will be nothing but the box of ABC. Okay, so what we have here is next R bar dot A bar, in this multiplied with B cross C as a vector is going to be this into B cross C. In fact, we can write this as box of ABC is a number, so we can just pull it out into x times of B cross C. So that is our R bar dot A multiplied with B cross C. This is just a scalar, so scalar multiplied with a vector. Here again we have this scalar multiplying the vector B cross C. Similarly, R bar dot B bar times of C cross A is going to be again box of ABC again into y times of C cross A. And R bar dot C bar times of A cross B will be equal to box of ABC again into Z times of A cross B. So when you add up all these three vectors, what do we get? Adding all the three equations, what do we get here? We get this box of ABC is a number, and we have x into B cross C, y into C cross A, and z into A cross. So I'm going to get the right hand side to be box of ABC into x. What is x times B cross C and y times C cross A and z times C cross B? A cross B. X into B cross C plus y into C cross A plus z into A cross B, which we know is nothing but here again R bar. So we have here box of ABC into R bar. Okay, into R bar. This is simply R bar. So the entire vector, when you add up all these three vectors, we get box of ABC into R bar. We want the magnitude of it. Therefore, the magnitude of the left hand side, LHS, after you add up, is going to be modulus of magnitude of ABC into magnitude of R bar. But he says that R bar is a unit vector. So magnitude of R bar is 1. Therefore, it's coming out to be modulus of magnitude, modulus of box of product of ABC there. So modulus of R bar dot A bar into B cross C plus R bar dot B bar into C cross A plus R bar dot C bar into A cross B, that turns out to be equal to modulus of box product of ABC into modulus of R bar. Modulus of R bar is given to be 1. Therefore, it comes out to be option 3 is the right answer. Option 3 is the right answer.